Welcome to Fire Engineering's Training Minutes. I'm Mark Gregory along with Ken Bailey and Paul Trahon. Today we're going to discuss the basics of torch operations as far as the fire rescue personnel are concerned. Guys?
Thanks, Mark. So what we have here is our standard oxygen and acetylene bottles. Our oxygen, being an oxidizer, is the primary function of the oxidization process when using an oxyacetylene torch. So hopefully all your regulators is backed off and set to zero, your bottles are off. When you turn on your oxygen, you turn it on very slowly because there's a phenomenon called heat of recompression. If there's any dirt, debris, or grease in between our oxygen valve and our regulator, we can get regulator burnout. So we turn on our bottle very slowly till we get our pressure up. Once that pressure comes up, we can then open it all the way and backseat the valve because we want as much oxygen flowing to our torch. We then come over to our acetylene tank. However, although this is a gas, there's a liquid acetone that stabilizes the acetylene gas within the bottle. We want to make sure that we turn that bottle on slowly as well. And we turn on our acetylene, we're not going to open it up all the way. We only want to turn it a half a turn and then another half a turn. That way, if anything bad happens at our tip, it's less than a full turn to shut off our fuel. Now what we have is our manufacturer's recommendation for setting our regulators, depending upon either the thickness of steel or the size of our tip. Today we're using a number 1 tip, and we'll turn in our oxygen to 35 pounds. We'll turn in our acetylene to 6 pounds. That will deliver enough mixture to the torch tip so Ken can light the torch.
So when we're lighting this torch, we're going to turn on, we have oxygen fed to the torch tip. We're going to go ahead and turn that completely on. We have actually 2 oxygen knobs. We have one at the base, which allows oxygen from the base up, and then we have one for our mixture. We'll talk a little bit about that. Our fuel is going to be on the red or the hash marked valves, and that tells us it's a reverse thread so that we know that we're putting the right hose to that valve. So we're going to just crack our acetylene using our striker, getting us a flame, and all that is burning right now is our acetylene. We're going to mix a little bit of oxygen using our top control knob, and this is really important here. Assuming that we have a clean tip, we're going to make this so that when I actuate the actual oxygen lever, that I don't have any deformation on the cones and that they're very nice and sharp. And that's probably a good set right there. Since we turned on the oxygen here, that allows oxygen to come up here, and we control that with our mixture of the acetylene on this control knob. But the actual cutting is the oxygen. And when I push this lever, that takes the molten metal and actually spits it out of the way, and that's what produces our cut. So we're going to cut this piece of flat stock. A couple of tips on that. We want to find the edge, if at all possible, if we're not having to do a plunge cut, and we're going to preheat that metal. And we're going to come just above it. We don't want to be too close to it because we can cause a backfire into the actual torch tip. So once we get it nice and hot, we're going to actuate the oxygen and we're going to start our cut, turning into it. And we want to travel at a speed that we don't have it come back together.
So one of the tips of the trade is being able to dissipate the heat that the oxygen acetylene torch creates. And if it's the only tool that's available to us, God forbid that there's a patient that's impaled on a piece of rebar, we can take standard HVAC duct seal and we can apply it to the steel, and with an ungloved rescuer's hand between the victim and the putty, we can actually cut the steel. The HVAC duct seal will absorb all the heat and protect the patient. be as simple as that. For $3, it could be make or break the rescue. So as we went through all the steps of lighting and cutting with the oxyacetylene torch, we could actually have a typed out, laminated step-by-step of all these procedures. We can actually have it memorized. However, if we don't take the flame and put it to the steel, we're going to lose that perishable skill. Mark?
I'd like to thank you for watching Fire Engineering's Training Minutes. On behalf of myself, Paul Trahon, and Ken Bailey, thank you.